Alright, the purpose of this video is to show the relationship between the tangential speed of an object that's executing uniform circular motion and its angular speed. First of all, we know that this distance s, measured along the circumference like this, s is equal to r times theta, actually by definition of the angle in terms of its radian measure, where r is the radius of the circle. So s equals r times theta. The tangential speed, v, is just equal to the change in s, delta s, over delta t, the change in time. So that's equal to delta r theta over delta t. But since r is a constant, I can write this as r times delta theta over delta t. And this thing right here is what we call the angular frequency. Omega is equal to delta theta over delta t, or the time rate of change of the angle. It's also referred to as the angular velocity, but that's a little bit of a misnomer used in this context. So omega is defined to be the time rate of change of the angle, and we get from this equation right here that v is equal to r times omega. Now, another useful equation in uniform circular motion, by the way, we abbreviate that as UCM, uniform circular motion. Another useful connection is the centripetal acceleration, which I've shown you in another video, is equal to v squared over r. But if I put in for v, r omega, square that over r, this is equal to r squared omega squared over r, and the r cancels one of those out, takes out one of those, so that the centripetal acceleration is equal to r times omega squared. Another useful equation. Now we also know that the frequency is just equal to 1 over the period. The frequency is 1 over the period, where the period t is the amount of time it takes to make one complete circuit when you're executing uniform circular motion. T can be written as the distance, 2 pi r, distance around the circle, divided by v. So that's equal to 2 pi r divided by v, which is r omega, and the r's cancel out. So t, the period, is equal to 2 pi over omega. That's another important relationship. And since f, the frequency, is 1 over the period, then f is just equal to omega over 2 pi, most commonly written as omega is equal to 2 pi f. So there's another equation that's very useful when you're dealing with uniform circular motion.